All right, let's take a look at DSMA 12 piecewise. So piecewise functions are really just that there's a couple pieces and it depends on what value of x you have of which function you're going to use. So you can see on this one, this is broken into two parts. I have one function over here and one function over here, and it depends on where you are on the x-axis. So let's take a look. So this is a piecewise function. It's also called a step function. So a parking garage costs $2 per hour, $2 per hour with a maximum charge of $12 per day. And so if you are there for 10 minutes or 30 minutes or 59 minutes, you get charged $2. Then once you go above an hour, then you bump up and you're charged $4, even if you stay an hour and a half. Or you stay an hour and 45 minutes, it doesn't matter. You still have the $4. And so that's why it's also called a step function. Our mail system is also that way. And then when you get past or when you get up to $12, you're never going to be charged more. So even if you stay 8 hours or 10 hours, it doesn't matter. You're still charged the 12. So it's always based on the x-axis. You're looking at the x-axis to see where you're going to go and how much you would be charged. The mail system is the same way. You can see here, it depends on the weight, right? And so as long as you are at 1 pound or less, this is an old chart, you're charged 39 cents. As soon as you go a smidgen over 1 ounce, not 1 pound, 1 ounce, then you will jump up to the 41 cents. Also notice that because you can't be both. If you're at 1 ounce, you can't be charged the 39 cents and the 41 cents. It's one or the other. So in this case, you're charged the smaller amount, the 39 cents. But as soon as you go just a smidgen past the 1 ounce, you'll be charged the 41 cents. And that keeps going. Okay, so we're going to be looking at some number lines, and we're going to do compound inequalities. So we're going to do and, we're going to do or. That's based on whether we have a union or we have an intersection. And so I'll show you that in just a minute. But let's just review real quick. If it's x less than 7, then it's going to point to the left, right? We're going to start just to the left of 7 and go all the way down to negative infinity. If it's x greater than negative 3, same idea, but this time we're going to point to the right. So we're going to head up to positive infinity. And so we're starting at negative 3 and we're heading to positive infinity. Now, if we're looking at and means that we only want numbers that fit in both of those inequalities. And so that means that we're only going to take where these two overlap. In this case, if you look at the blue on the top, we have all of these numbers, and they're going to go all the way to negative infinity. If you look at the red on the second one, they're going to go all the way to positive infinity. But because we have the word and, we only want the numbers that fit on both of those. Well, the numbers that fit on both of those is right here in the middle. Right? These are the numbers between negative 3 and 7 are numbers that are on both of those number lines. And since it's and, that's what we're going to take. If it were or, that's different. Or means that we could take everything. But and it has to be on both of them. And so that's actually called an intersection. Now this asks you to watch a lecture video that is not there. I apologize. So you're watching it now. This is looking at a union. So a union means that we're going to look at everything, and a union actually ends up being or. So we want to know all of the data that's in A or in B. And so that means we end up taking everything. If it heads said the intersection, then the intersection is actually an and. That's the slide we looked at just a minute ago. That means that we only take the data points that are in both. So they have to be in set A and in set B. All right, let's look at this one. We have x is less than 3. That means we're going to point to the left. And we have an open circle or a parenthesis, whichever way the problem wants it. Then we have x greater than or equal to -1. That means we're going to point to the right. We want to head up to infinity, and we're going to have a closed-in dot or a square bracket depending on the problem. So this problem wants or. Because it wants or, we can take everything. It's either in the first inequality or in the second inequality, and that means we end up with every single number because we have all the numbers way out here. We have all of these numbers in the middle, and we have all the numbers this way. And so our answer ends up being everything. Now, if they had asked for an intersection, or if they had said and, then we could only take the items that were in both of the inequalities. Okay, so this problem wants an or. We've got x less than 2, so I drew that number line. We have x less than 6, I drew that number line. And we want everything. It's not an and. It doesn't have to be on both number lines. It has to be on one number line or the other. And therefore, we can take everything starting just to the left of 6 all the way down, because these numbers are here. They're not on both, but that's okay. They're here. And then all of these are on both of them. And so we actually can take everything to the left of 6. Okay, this one is also an or. So my first number line, my first inequality is x greater than 4. I'm going to head to the right. The next one is x less than 6. I'm going to head to the left. And because we want or means everything. It's on one number line or the other. So I end up getting everything, right? Because all numbers are on one or the other. So it looks kind of crazy, but we're going to shade in the entire number line. And then if they ask for interval notation, remember with number lines that on this end we have negative infinity, on this end we have positive infinity. So since we can use every single number on this number line, we're going to go from negative infinity to positive infinity. Okay, so for this one, instead of an inequality, they're actually giving me a line. And so I have this line, y equals 5x plus 4, and then I have this line, y equals 2x plus 7. And so our deciding factor of which line we're going to use depends on x. If x is less than 0, I'm going to use the 5x plus 4. If x is greater than or equal to 0, I'm going to use the 2x plus 7. So let's take a look here. The first one they want me to use is -3, right? F of -3. That means that x is equal to -3. Well, -3 is less than 0. So since it's less than 0, which is my indicator up here, then I'm going to use the 5x plus 4. And all I'm going to do is substitute. We did a little of this a long time ago. I'm going to substitute -3 in for x. And what pops out is -11, and that's my answer. Functions are like machines. You've got an input and an output. Okay, the next one I have f of 0. That means that x equals 0. Well, if x equals 0, I want to use the second one because that says x greater than or equal to 0. So that means I need this 2x plus 7. I'm going to put 0 in for x, and that gives me 7 back out. And then finally on the bottom, I've got x equals 3. So 3 is greater than 0. That means I need to use the 2x plus 7, the second function. I substitute 3 in, I get 13 out, and I am good to go.